Okay, one of the other formulas we saw in the formula sheet dealt with mutually exclusive events, which is in 8.7 now, page 360. It's really a simple idea, and we're going to look at 3 problems to show examples of it. Things are mutually exclusive if the 2 events are such that they both cannot happen at the same time. So the Venn diagram that those go with is the disjoint sets diagram. So if the event sets don't have any intersection, or if the intersection's empty, that's what we say, then they're mutually exclusive. So we're going to look at these 3. They all deal with rolling dice, and so we're going to look at the outcomes that come from that. I think it would have been easier to shift over and get out of the light here. So we'll look at the whiteboard here without the reflection on it. Okay, let's look at the very first one. It says we're going to roll an unbiased 6-face die, and let's let A be the event roll a square, and B be the event roll a factor of 6. So for number 1, what we're going to look at is A is a set of outcomes, and now each outcome is going to have 2 dice outcomes on it. And the first one is we're going to roll a square. Okay, well, a square number that you can't roll a 1, the smallest number you could roll is 2. And so the smallest square you could possibly roll is a total of 4. So there's a couple different ways you can roll a 4. You can get double 2s. You can get a 1 and a 3. And then it's important to also see that 3 1's a separate outcome. There's 3 different ways of rolling 4 on the dice. Let me zoom in a little, make sure this is clear. All right, all those are outcomes that total 4, and that's a square. Okay, that's the only way to do it. Now, let's see, what other totals can you get? Well, you get 5, 6, 7, none of those are square. The next highest square is 9. So how could you get a 9? Well, you could roll a 3 and a 6. You could also roll a 6 and a 3. Right? Every roll could go in one order or the other. Okay, that's a total of 9. Well, you could also roll a 4 and a 5, or a 5 and a 4. Those total 9. And then you might think, well, there's 2 more, but I already counted the ones that started with 6. So this is the set of all the outcomes that total up to a square. Okay, now let's look at the other event. The other event is roll a factor of 6. Okay, well, you have to know your factors there. 1 is a factor of 6, but you can't roll a 1. 2 is a factor of 6. You could roll a 2 with a 1 on each die. So 2 is a factor of 6, there's only one way to roll it. With every factor of 6, you should think about the other factor. So 2 times 3 is 6, so 3 is another factor of 6. How can you roll a 3? You get a 1 and a 2, or a 2 and a 1. That's the only ways to roll a 3. Okay, so that deals with 2 and 3. We already disposed of 1. The only other factor of 6 is 6 itself. So how can you roll a 6? Well, you can get a 1 and a 5, or a 5 and a 1. Those are 2 ways to total 6. You can get a 2 and a 4, or a 4 and a 2, or you can roll double 3s. And that's it. So you either roll a 2, 3, or 6 if you're rolling a possible factor of 6. So now if you look at all those outcomes, there aren't any in common. None of the factors of 6 add up to a perfect square. The factors of 6 are 2, 3, and 6. None of them are perfect squares. None of the perfect squares are factors of 6. They're 4 and 9. So there's no intersection here. These 2 sets do not intersect, so they're mutually exclusive. So A intersect, let's write it this way. A intersect B is the empty set, so therefore they're mutually exclusive. All right, that's the first one. See how much room we've got? Let's tilt up a little bit and go to the next one. The next one says you're going to roll a pair of dice again, and the first event is roll a 4. Okay. Well, now you sort of see how to do this. If we're going to roll a 4, you can get a 1 and a 3 and a 1, or a 2 and a 2. There, that's it. That's the only way to roll a 4 on a pair of dice. Okay, so there's not that many outcomes. Then the next event we're looking at is let's let B be the event roll a 6. Okay, so how can you roll a 6? You can get a 1 and a 5, 5 and a 1, 2 and a 4, 4 and a 2. Or you could roll double 3s. And that's all there is. Those are the only ways to roll 6. Now, once again, none of the outcomes are in common. And we should have really, you could see that without even writing the outcomes. This proves it. But how could an outcome be a total of 6 and at the same time be a total of 4? There's no way it could happen. So this is also a situation where they're mutually exclusive. A intersect B is empty. Okay? So they're mutually exclusive again. Let's look now at the bottom of the board for the third one. The third one says, let's roll an unbiased die again. We're going to have a few outcomes here, so actually I think what I'm going to do is erase what we've got there and use that whole area for this next problem. Number 3 is going to take up quite a bit of room. So let's get rid of 1 and 2 here and go on to number 3. Okay, the first part of 3 says we want to roll a prime number. Okay, we want to roll a prime number. Turns out there's a lot of ways to roll a prime number. We're going to think of what your primes are between 2 and 36. So let's write them out. Primes. Okay, 2, 3, not 4, 5, not 6, 7, not 8, not 9, not 10, 11, 12, 13, 14, 15 is not prime, 16, 17, 18, 19, 20, 21, 22, 23. Okay? Well, actually, we've gone further than we have to. Ours going up to 36. That's the number of different possible outcomes, but the total on the dice only go up to 12. So actually, we can stop right here. After we get to 11, that's the highest prime you can roll. Okay. So now we have to write outcomes down. Let's write outcomes down that total up to 2. Well, there's only one of them. 1 and 1, total up to 2. That's it. How can you roll a total of 3? Another prime. Well, 3 can be gotten as 1, 2, or 2, 1, and that's it. How can you get 5? 1, 4, 4, 1, or 2, 3, 3, 2. Those are all ways to roll 5. Make sure I didn't go off the board there. A little bit. Back up a bit here. Now I think we've got them all. Okay. All right, so that's rolling a total of 2, 3, 5. How about 7? How can you roll 7? There's a lot of ways to roll 7. You can roll 1, 6, or 6, 1. 2, 5, or 5, 2. You can roll 3, 4, or 4, 3. As we saw when we played craps, that is the most likely number total to get on rolling 2 dice. There are 6 ways of doing it. So there's 6 out of 36 ways of rolling a total of 7, the most likely roll total of any others. Okay, how about 11? Well, if you're going to roll 11, you're going to need a 6 and a 5, or a 5 and a 6, and that's all there is. Okay, that's quite a lot of outcomes. Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 outcomes. So if that's A, the cardinal number of A is 15. Okay. Interesting thing. We don't really need to know the cardinal number, but it is an important thing to make sure to do in probability is count your outcomes so that we can answer questions on it. Okay. That's for event A. Event B is roll an even number. Okay, there's a lot of outcomes for this one too. So let's let B. Well, let's roll an even number. Well, let's figure out what the even numbers are. These are even totals from 2 to 12, both of which are even. 2, 4, 6, 8, 10, and 12. Those are our even totals. Okay, so how can you roll a 2? Well, a 1 and a 1. That gives you a total of 2. Total of 4, 1, 3, 3, 1, 2, 2. Total of 6. Well, that's 1, 5, 5, 1, 2, 4, 4, 2, or 3, 3. Let's get another marker. Now let's finish with the black one. All right, so that's a total of 6. Now we're doing 8. Well, you can't roll a 1 and a 7, but you can roll a 2 and a 6, or a 6 and a 2, 3 and a 5, or a 5 and a 3. Okay, we already did the 6, so that one's done. That's a total of 8. How about a 10? If we're going to roll 10, well, let's see. We'd need a 5 and a 5, or a 6 and a 4, or a 4 and a 6. All right, and then to roll 12, there's only one way to do it, double sixes. Okay, now this is going a little fast, but you might need to consider them more. We're looking at outcome spaces in the next section. We've actually already looked at a grid of 36 dots for the outcomes of dice. One way or the other, you want to straighten out in your own mind that that's how many we've got. And now if you look at this, what you see is that we've got a couple in common here, okay? There is an even and a prime here, 2. Okay, 2 is even and prime. So in this case, A intersect B is not the empty set. There is a way of rolling both of them, so they are not mutually exclusive. So they're not mutually exclusive. And that's what you're asked to find out. Are they or are they not mutually exclusive? This is not naturally, as soon as you find one outcome that's in the complement, or I'm sorry, in the intersection, you really don't need to do any more. Once you've found one element, once you've found that the intersection's not empty, the problem's over. They're not mutually exclusive. Now what we have also, we'll see in the next section, well it's the same section, the next part of this section, is that mutually exclusive events are always dependent. If one happens, that influences the likelihood of the outcome of the other. So in the next video, we're going to look at independent events. It's a little more complicated.